Hello and welcome to Newman University. My name is Dr. Andrew Toon. I'm the subject head of mathematics here at Newman University. And I'll like to talk about, in this mini lecture, talk about COVID-19 and three items that are usually mentioned in the press. The number R, a so-called related number R0, and herd immunity. Okay, so let's first of all talk about the number R. Okay, this is a very important number and it's called the effective reproduction number. So R, as very often mentioned in the press, in the media, R is the average number an infected person goes on to infect in a population where some people are immune. Okay, and it is well known and well documented that if R is bigger than 1, this means essentially that the epidemic will grow. It will grow out of control and more people will become infected, which of course is devastating. What we really want is R to be less than 1. Okay, and this implies that the epidemic will decline and hopefully completely disappear from society. So this is a scenario that we really want as a society, for R to be less than 1. And that's why we have things like lockdown and self-isolation in order to prevent the epidemic from growing. I mean, ideally, we would want a vaccine to vaccinate everybody, but if that's not, well, that is not yet available. So the only option really is to self-isolate and try and reduce contact amongst ourselves as much as possible so that the epidemic cannot spread. The other possibility is when R equals to 1, and this is when the epidemic, in our case, of course, COVID-19, will remain the same, will remain as it is. Okay, and this is a sort of status quo situation where the epidemic just sits there as it is. It's not increasing, it's not decreasing, it stays where it is. Of course, what we want is R to be less than 1. Okay, that the on average, a infected person will infect less than 1 person on average. Okay, so that's the ideal situation. So that's R. That's very often talked about in the press, and it's pointed out in many situations, many times that R is bigger than 1 presently, and of course it will vary from region to region in the UK. Okay, we have hotspots where where COVID-19 is spreading quite rapidly, and of course we have a few soft spots where the R value is less than 1. Okay, but the ideal situation in order to eradicate the disease is for R to be less than 1. Okay. A related number is R0. This is the basic reproduction number. So R0 is the average number of people an infected person goes on to infect when everyone in the population is susceptible. Okay, so in other words, nobody is immune. Okay, so it's very different from R. Okay, where in that case, some people in the population are immune. That's because they've had it already, and perhaps they are immune because of that. And there is no vaccine presently, but if there was a vaccine, of course, some people in the community would be immune. But of course, R and R0 are related. You know, in fact, R is proportional to R0. Okay, obviously the bigger R0 is, the bigger R will be, and vice versa. So another way of writing this, or the R equals some constant S times R0. Okay, and S is what we call is the proportion of the population that is susceptible to catching the disease. In this case, obviously, COVID-19. Okay, so let's do a little example of what this means. So if half the population is susceptible to the disease, this means that S equals 0.5. Yeah, because half of the population is susceptible. Therefore, R, which equals SR0, which equals 0.5 R0. Okay. So we can see, so therefore, if R0 is less than 2, okay, this would imply that the R value is less than 1, and hopefully and there will be no epidemic. Okay, so we get to the situation where R value is less than 1, and hopefully the disease will disappear and society will be safe. Okay, so two important numbers that are often mentioned in the press: there's the effective reproduction number, R, and there's the basic reproduction number, R0. Okay, so R refers to the average number of an infected person that goes on to infect in a population where some people in the population are immune, okay, for whatever reason. And R0 is the same thing, but everyone in the population is susceptible to catching the disease. Okay, this brings us nicely to the notion of herd immunity, okay, which are related to these numbers R and R0. So herd immunity, this occurs when many people are immune, enough people in society are immune, such that the disease cannot grow into an epidemic. Okay, it doesn't have a chance to spread because there are enough people in the community, in society, that are immune, so the disease cannot be spread. So this also protects people who are not immune, because if a disease cannot spread, that means people who are not immune cannot catch it, hopefully. So the important question is how many people do we need to immune in order to have a disease that will hopefully disappear? Okay. So our starting point here is that we need our R value to be less than 1. Okay, which of course is S R0, and we need that to be less than 1. Okay, so therefore SR0 needs to be less than 1, and we can divide through by R0. Sorry, this implies that S has to be less than R0. So remember what S is. Okay, S is the as mentioned above, S is the proportion of the population that is susceptible to catching the disease. Okay. So therefore, oops, sorry. So therefore, 1 minus S clearly equals the proportion of people not susceptible okay, i.e., in other words, this equals the proportion of the population who are immune, who cannot catch the disease. Okay, and that's, of course, we want that number to be as high as possible. So therefore, we know that S is strictly less than 1 over R0 in order for the disease to disappear. If we multiply both sides by -1, this implies we have minus S. Because we're multiplying through by -1, as you all know, we must reverse the sense of the inequality, equals -1 over R0. S and R0 are positive numbers. And of course, we can add 1 to both sides to get this importance equation here. Okay. So this will tell us the proportion of society that we need to be immune in order for the disease to disappear. Okay, so in words, let me just write that. Therefore, for herd immunity, that is the proportion of our herd is the UK population. For herd immunity, we need to ensure at least 1 minus 1 over R0. Remember, 1 minus S, as indicated above, is a proportion who are immune, who cannot catch the disease anymore. We need at least 1 minus R0 of the population to be immune. Okay, so for herd immunity, we need to ensure at least 1 minus 1 over R0 of the population to be immune. Okay, so for example, to put some concrete numbers to this, so an example, if R0 equals 2.5, that means an average person, a person on average will infect 2.5 other people on average. That means 2 people will infect 5 people on average, when everybody in society is capable of catching the disease, when everybody is susceptible. Then 1 minus 1 over R0 equals 1 divided by 1 minus 1 over 2.5, which equals 0.6. Okay, and this means 60% of the population must be immune. At least, in order for the disease to go away, in order to have R to go to less than 1. Okay, at least 60% of the population needs to be immune. And that's why a vaccine is very, very important, so that at least 60% of the population can take the vaccine and therefore become immune. So in this mini lecture, I've talked about R0, and herd immunity. Okay, so herd immunity is very, very important. And how can this occur? So herd immunity can either occur by vaccination, as we all know, that's not quite ready yet, or by people becoming sick and hence being immune from the system, from the disease. Okay, and of course we want that to happen without any fatal consequences. So herd immunity is where the herd, the immune proportion of the population, will protect those who are not immune. Okay, so herd immunity not only protects the individual, but also those, for whatever reason, cannot be immune. Okay, so that's an ideal situation for us to be in order to force R to be less than 0. So vaccination and immunity is therefore not just for the individual, it is there for the whole herd, i.e. for all of humanity. And this will ensure that R will be less than 1 and the disease will run its course and disappear from society, hopefully forever. Okay, so I hope you found this mini lecture useful and enjoyable, and hopefully it gives you some idea on how we teach mathematics here at university online. Okay, and I hope you can come and see further mini lectures that we will be uploading for you to view. More information on what we just talked about can be found at the Plus magazine. If you do a Google search, you can find that, and there's a lot more information there on the mathematics related to COVID-19. So thank you for coming. I hope you have a good day, and we all hope to see you at Newman in the very near future. Stay safe and stay healthy, and bye for now.